Hi everyone, this is our first video lecture on significant digits. So first I want to start off by looking at a couple measuring devices. We have a standard ruler and we also have a dial caliper, which is right here. So we're going to be using these two items today to measure some items and see how the precision of these measuring instruments determines the number of digits that we write down on our paper. So I just have a pad of paper here, and I'm going to measure the thickness of this pad of paper. And if I line it up, you can see that it's roughly 4.2 millimeters. Everybody see that? So again, it's a little bit difficult to see, but it's just past that 4 millimeter mark. So we're going to call that 4.2 millimeters. Now, why did I write 4.2 rather than 4 millimeters? This is why. If I look at my measuring device, all of my measurements are all the known values plus one estimated digit. So if I look at the markings on my page, or on my measuring device, I have markings every millimeter. So that's the ones digit. And then I estimate to the next digit, which would be the tenths. So again, I was here, and then I was a little bit past, so I would say that that is 4.2 millimeters. 4 millimeters would be used in a measuring device that did not have the millimeter markings here, just the centimeter markings, because this would be 0 millimeters and then 10 millimeters. If it was in this area, I would call that 4 millimeters, where the 0 would be my known value and the 4 would be my estimated number. Now, what happens if I remove a sheet of paper? So if I take this off and I remeasure it, what am I going to get for my value? And if I line it back up, you can see that it's still 4.2 millimeters. It doesn't change. Did the thickness of this object change? Well, yes, because we took a piece of paper out. This has a thickness. But is that thickness detectable by this measuring device? No, it is not precise enough. So let's look at a different measuring device. Here we have a dial caliper. This reads to the hundredth of millimeters. And you can see that when I roll the wheel out, you can see it change values. So let's use it to measure our device, or our notepad. So if I look here and squeeze it, I get a value of 4.13 millimeters. So I'm going to write that down. Now, let's say I take a piece of paper away from this one, and I measure again. Should the value change? And you can see that it does. It gives me a little bit different value because I'm able to pinch it nice and tight to see that, but you can see now it's 3.97. So because of the precision of my instrument, my number precision is greater. So I now have greater decimal places because of the device that I'm using. So how does this come into play? Well, let's take, for example, this Sharpie. And if I were to measure this Sharpie with this particular meter or ruler, I'm going to measure this at 13.5254. 13.54, and this is now centimeters because I was looking at these markings here. These are centimeters. Okay, so that's for my pencil. And now I'm going to add this slip of paper to it. And I'm going to use this to measure how thick a sheet of paper is. It's 0.08 millimeters. So I have 0.08 millimeters, and I want to determine what is the total thickness or length of my Sharpie with the paper on the end. So if I were to put the piece of paper right on the end, what is the length of that? Let's do a quick conversion. Millimeters to centimeters. So this is 0.008 centimeters. So I'm adding 13.54 centimeters to 0.008 centimeters. And when I do that, I look at my values that I have. And the number that I have here is to the hundredths place. And the number I have here is good to the thousandths place. Do I know the thousandths? Let me move this unit over here. Do I know the value that's in this spot right here? That's questionable, because I don't know what it is. I really don't even know what this 4 is, because remember, I estimated that. So there's some uncertainty in that number as well. And this 8 has some uncertainty in it because it was a measurement. So when I'm adding these two numbers together, I have uncertainty plus 8. That's 8 with an uncertainty to it. I have an uncertain 4 with a 0. That's 4 with an uncertainty to it. I have 5 plus 0. Those are both numbers that I know. I have 3 plus 0. Those are numbers that I know. And 1 plus 0, both numbers that I know. So when I'm reporting this value on my paper and I add those numbers together, I'm going to report all the numbers I know plus one uncertain one, just like I did up here. All my measurements are all the numbers I know plus an uncertain. All the numbers I know plus an uncertain or estimated number. So when I look back here, the number that I'm going to put on my paper is 13.55 centimeters. I can only measure to the least precise instrument. So if I was measuring with the ruler for one of them, then that's only as precise as I can get when I'm measuring or when I'm adding the two together with different precisions. Okay? So the number of decimal points or places tell me the precision of my measuring instrument. So hopefully that makes sense. With multiplication, we use the number of significant digits, but it's really an addition rule. For example, if I take the number 4.2 millimeters that we looked at before and a number of 13.54, and we'll just call these millimeters as well, and I multiply these numbers together. Remember where our uncertainty is. Uncertainty is in the 2 and it's in the 4. So if I multiply 4 times 4.2, I get these numbers. So 4 times 2, 4 times 4. And since this 4 is uncertain, all these numbers have uncertainty. When I take the 5 and I multiply by these, so I put a 0 here. 5 times 2 is 10. 5 times 4 is 20, so that's 21. The 5 is known, but the 2 is uncertain. So these numbers were uncertain because that 0 came from this. And then this right here is a certain value, so those are certains. And I go to the next. 3 times these. 3 times 2 is 3 times 4. Again, there's uncertainty in that 2, so this 6 has uncertainty in it. And then I finally do the 1. And again, uncertainty in the 2. So when I add them, again, I add all this up, get 8, 6, 8 point. And again, that should be what I get on the calculator. So you can see that's what I got in the calculator when I punched that in. But if I look at this number, look at my uncertainty as it carries through. Uncertainty in these numbers, so there's uncertainty in that 8. Uncertainty in these numbers, so there's uncertainty in the 6. Uncertainty in this number and this number, so there's uncertainty here. There's uncertainty in this 2, so there's uncertainty there. So when I report this on my page, the only number that I know for sure is this 5. And I go to the next one that's an estimated one, which is this 6, but I look after it. It's an 8, so I round up. So the number on my page is going to be 57. And if I looked at units, millimeters times millimeters, I'd have a millimeters squared. But the multiplication rule is just the addition rule in terms of its function, but it's a quick way to do it. So we look at the number of digits. So this first number has 2 significant digits, and this number has 4 significant digits, so we go by the least number, which is 2, and if you notice here, that is correct. Our answer came out to be 2 significant digits. Thanks for watching. Hopefully this explains a little bit more about measurements and significant digits and why we use them. Thanks. Have a good day.